algebras. Welcome to Chapter 6, Lesson 4 notes, multiplying polynomials. We are going to start talking about using our exponents rules to, as we multiply terms together, get kind of simplified terms using our properties of real numbers, exponents rules that had gone into creating those properties of real numbers, and getting kind of into distributing terms as well, so that we can get into the much bigger piece, which is the double distributing or the binomials multiplying together piece. Okay. So it kind of will go gradually, right? And to review, the commutative property is one of our properties of real numbers that tells us that it doesn't matter what order you multiply two numbers together in, you will get the same result. So 6 times x is the same as x times 6. That's what we're getting here. And of course, that simplified result is 6x. The associative property tells us that we can group any factors together in any order and still get the same result. So what that means is when you go to multiply 5 times x times 6, what you can do is take 5 and 6 and group those together first and then multiply that result by x. Because it doesn't matter that group. If it's all being multiplied together, put together the number terms and multiply those first, which is what we do in this scenario. We're still going to get the same result, which is 30x. Then the distributive property tells us that it doesn't matter if we add what's inside the parentheses first or we multiply by what's inside the parentheses first. Either way, it's going to come out in the wash as the same result. Now, that is really typically looked at better with all numbers. But now that we're in the polynomials unit and now that we're talking about polynomials, we really need to understand that that is used here backwards. That's telling us that now, okay, start by multiplying. Because if you start by multiplying and distributing through, giving everything inside the parentheses that -2, then you'll get these two unlike terms and in the correct spots. Okay, because I cannot actually add these two things up any further. But the best way to simplify this particular situation is to actually distribute this -2. So the reason we talked about the distributive property back when we were talking about just numbers was so that we could bring it to this point and do this particular act where we take that thing outside of the parentheses and we multiply it throughout the parentheses. Maybe one time, maybe two times, maybe three times, right? Depending on how many things are in our parentheses. So that's how the properties of real numbers are being used here with our polynomials. Okay, that's how the properties of real numbers are getting used with our polynomials. So quick review of things that we've already covered with our exponents rules and with kind of what I've just talked about reviewing those properties, right? So in this particular case, in number 1, you've got 3a squared b and you've got 4ab cubed. Well, this is a case of everything is being multiplied together. So in your head, use the associative property to group the right things together. Okay. So I'm going to, in my head, group the 3 and the 4 together to get 12. I'm going to, in my head, group the a squared and a together to get a to the third. I'm going to, in my head, group the b times the b cubed to get the b to the fourth. And that's my final answer. Number 2, same deal. Okay, group the numbers together. So, and again, notice I'm not rewriting that work part. I can if that's what I need to do, but you don't have to, because you should have practiced this so much in past years that this is kind of becoming, this is, oh yeah, okay, I've done this is fine, whatever, right? So again, if you need to do that, go ahead, group them as 2 times -4 and group them as x times x squared and y times y and z times z cubed, right? So go ahead and do that if you need to. If you don't need to, don't worry about it. Don't do that. You don't have to show that piece. So in my case, it's going to be 2 times -4 is -8. X times x squared is x to the third. Y times y is y squared. And z times z cubed is z to the fourth. Okay. Real quick, I'm just going to take this opportunity to remind you about how to figure out the degree of a term. Since this term has multiple variables raised to multiple exponents, you add the exponents up, and that result is the degree of the polynomial. So this polynomial is a 3 plus 2 is 5, 5 plus 4 is 9. This is a ninth degree polynomial. Okay? Or excuse me, ninth degree term, because there are not multiple terms here. Speaking of multiple terms, let's get into number 3 and number 4, where you've got a number on the outside of the parentheses, and the only way to simplify the situation is to distribute that number. So I'm distributing -4. -4 times x is -4x, and -4 times -5 is +20. And there you go. 2 terms, that means that's a binomial. 1, 2, right? 2 terms, binomial. Distributed, right? Negative times negative gives me that +20. So you do have to pull that sign throughout the parentheses in multiplying as well, okay, of this front term. And number 4, you got a 3x back here. And so let's distribute that 3x, right, by all these terms. 3x times -2x squared is -6x cubed. 3x times -4x is negative 12x squared, and 3x times 9 is +27x. Now you'll notice that since the front term had an x in it, all of my subsequent terms in the parentheses had a change in x as an exponent, right? And all the x exponents we changed by 1 because we multiplied through an x to the first power. So this is really 1 plus 2 gives me this 3 exponent here, because that's the exponents rules we talked about back in lesson 3. Okay? This is always where you should take a sec to make sure you understand those first problems. That's the first, that's multiplying, single term times single term, or distributing a single term throughout parentheses. Okay, so single term times single term, distributing a single term throughout parentheses. Now we're going to multiply binomials. And as I just reviewed, binomials are polynomials that have 2 terms. So if you have 2 polynomials that have 2 terms that are multiplying together, you have a situation that we like to call FOIL. And FOIL, of course, stands for first, outer, inner, last. And that's what I'm going to talk about when I go through my foiling pieces and simplify for my final answers. Okay. So let me just review what FOIL stands for again. First, outer, inner, and last. FOIL is an acronym standing for the 4 types of multiplication you do when you multiply together 2 binomials. So in a situation like number 1, I've got a binomial of x plus 2, and I've got a binomial of x plus 5. And I know they're being multiplied together because the end of the first parenthesis and the front of the second set of parentheses, they meet up with no other sign between them. If there was another sign between them, then there was another operation between them I would have to do. But there's not. So that's indicating that this is a multiplication problem. So let me show you how FOIL works, and it's probably going to be familiar to you. You've probably done FOIL before, but again, let me show you how it works. It's just double distributing, okay? So what I'm going to do is I'm going to distribute the x first in the front set of parentheses. So this x is going to have to get multiplied by both things in the back set of parentheses. This is the first terms multiplied together, x times x being x squared. This is going to be the outer terms multiplied together. X times 5 is a positive 5x. And yes, I want you to have that sign with it on that line. That's going to be important. Now I've distributed the x throughout both things in the second set of parentheses. Now I got to do the same thing with the 2. So the 2 gets multiplied. These are the inner terms multiplying together. 2 times x is a positive 2x. And then the last terms of each binomial multiplied together are 2 times 5, which is a positive 10. Now I want you to notice something about the 4 terms of the FOIL. What happened here? Well, x squared does not have a partner. 10 does not have a partner, but the middle 2 terms are like terms, which means they have to add up and combine to give me a simplified answer, right? And we'll continue going in simplest form, standard form, meaning descending exponential order. So we'll start with our x squared that does not have anyone to combine with. Then you've got 5x plus 2x is 7x in the middle. And you've got a plus 10 at the end. And this is why those signs were important, because these are unlike terms. So when they simplify at the end, that's the most I can combine any terms, is those 2 middle like terms. Okay. If you have 2 binomials where the x is raised to the same exponent, your middle terms will be able to combine. Okay. So that is going to be the case. Sorry that my cursor is right in the way there. That is going to be the case on number 2 as well. All right. Number 2 is also going to start with first. Okay. 2x times 3x. Well, that's 6x squared. Okay. Outer 2x times negative 4. That's a negative 8x. So my 2x from the front binomial has been distributed. Now I've got to distribute this 1. Anything times 1 is itself. So 1 times 3x is a positive 3x here for the inner terms. And 1 times negative 4 is a negative 4 for the last term. So notice this time, my middle terms have different signs. That's okay. We know how to deal with that. Different signs, they actually subtract, right? So negative 8 minus negative 8 plus 3 is a negative 5x for the middle. Nothing like the 6x squared, so that goes first. Negative 5x in the middle. And nothing like the minus 4 at the end, so that goes last. Descending exponential order. Simplest form, standard form. I'm sure FOIL is familiar to you. You know, again, like I said, I'm sure you've seen it before, but I really will practice FOIL a lot. It's going to end up being really important that we understand this multiplying piece when we get into chapter 7 next. So there's a reason that we kind of end with this in chapter 6. These next 2 lessons talk a lot about FOIL. There's a reason for that, and you'll see it right away in chapter 7. Okay? Remember, always email me, ask some questions, come to class. That's always the best way to ask questions, live, in person. Here we go. Some examples. So what you're going to see me start doing as I practice is I'm going to start to be able to see some patterns, and I'm going to start pointing those out to you as I go so that hopefully you can also see the patterns. Okay? So let me start here with saying, first thing I'm noticing about my 2 binomials that are multiplying together is that they have different signs on the inside. Okay, so I want to see the pattern that occurs here. Let's start with our firsts. X times x is x squared. X times negative 5 is negative 5x. I'm going to do something different this time now that I don't have those lines that I have to fill in. And when I distribute the 4 times x gives me a positive 4x, but I'm actually going to line it up right under the negative 5x. And I just want to show you that for the future when I have more terms that I'm distributing. And then, of course, 4 times negative 5 gives me negative 20, my last, right? And so then what I do is I can just line up those like terms vertically and bring down my final answer of x squared minus 1x, or just minus x, minus 20. That's my final answer. Now, what do you notice here? You notice that because these terms had different signs, they subtract to get the middle. Okay. It's so far, it's always been the case that these front terms are giving me, right, an x squared, x times x giving me an x squared, or because I've only had an x to the first power in both binomials so far, that's what's been happening, right? Okay. In number 2, I notice right away that these have the same sign in the binomials. They're both minus, right? So let's see. Let's start with first, right? X times x is x squared. X times negative 5 is negative 5x. Now I'm going to do the same thing I did before. So negative 2 times x is negative 2x. So I'm lining up vertically. And negative times negative is a positive 10 for my last term. Okay. All right. Something else to note, right? So let's combine like terms vertically. Oh, well, they're the same sign. So really you just add up the number and keep the sign in front. So you get x squared minus 7x plus 10 as your final answer there. Make sure you're practicing right along with me. Okay, make sure you're practicing right along. Number 3, front terms, right? First terms multiplying together. X times x is x squared. Outer terms multiplying together. So x times positive 3 is positive 3x. And then my inner terms multiplying together. Negative 9 times x is negative 9x. And my last terms, different signs. So a negative 27 as the end for my last. And let's add, let's see, x squared minus 6x, right? Because those were different signs. And bring down the minus 27. Well, I've noticed right away that if my end term is negative, I'm subtracting my middle term. So I'm noticing that my end term can only be negative if I have different signs inside both binomials, right? One is a plus, one is a minus. If I have the same signs inside my binomials, my end term is positive, and I'm adding to get the middle. Those are things to keep in mind. Okay? Those are things to keep in mind. Alrighty, continuing on. Let's see. X times 3x, that's 3x squared. X times 11 is positive 11x. Cool. In the inners, it's 6 times 3x. I almost said it out loud. 18x. Positive 18x right here. And 6 times 11 is a positive 66 at the end. And again, just the middle terms are adding up, right? So I get 3x squared plus 29x plus 66. There we go. Again, 4x times x is 4x squared. 4x times 12 is positive 48x in the middle. Negative 7 times x is negative 7x. And negative 7 times 12, oh, what's that? 84? No, I think that's 14. Oh, look at that, a calculator right on my screen, and yet I grabbed for this one. That's just how I am. I was right, 84. Get out of here. Minus 84. There we go. Combine like terms, 4x squared. Ooh, okay, we've got to do some subtraction here because those are different signs, right? So 48 minus 7 is a positive 41x in the middle and minus 84 at the end. So again, if they had the same signs, I had my end term positive and I was adding to get the middle. And again, I had different signs, so I was subtracting to get the middle, and my end term was negative. So that's a pattern that's occurring when you multiply binomials together. Okay. Last, but certainly not least, number 6 here. 2x times 3x is 6x squared. 2x times 2 is positive 4x in the middle. Negative 1 times 3x is negative 3x. And negative 1 times 2 is negative 2 at the end. Again, different signs, right? So we were subtracting to get the middle. Again, that was the case. 6x squared plus 1x, or just x, right? Minus 2. Notice in both of those scenarios where I had an x in the middle, I said 1x or x, because I just want to remind you that having a single x present is saying 1x. So 1x is equal to just x. Those are equal to each other. So if you are someone who wants to write the 1 in front of the x here, or wants to write the 1 in front of the x here, I'll do it on this one. You can't. It means the same thing. I typically don't, so don't get used to that from me. Okay, I don't, if I see an x, I know it's a 1x. Okay. All right. We're going to get into taking a binomial and multiplying it through a trinomial. If you consider that, very similar to FOIL. We can't call it FOIL because FOIL is for multiplications specifically. But when we're talking about this, we are still talking about the same deal, double distributing, right? Distribute the first piece from the first one throughout everything behind it. Distribute the second piece from the first one throughout everything behind it. So in this case, what I'm going to do is I'm going to use the same problem twice. And I'm just going to show you, you can continue to do what I was doing in kind of an extended FOIL situation, or you can do something called the box method. Either one is fine, okay? But it's just how you're getting to your final simplified answer. So I'm going to show you both. And I kind of set up these to do them a specific way to get you set up for this right here, distributing when you've got a binomial times a trinomial, okay? So we're going to get the same answer out of these two problems because they're exactly the same problem, just so you know. Let's start with how I've been doing things. Start with the first term and distribute it throughout. X times x squared is x cubed. X times 3x is positive 3x squared. X times 4 is positive 4x. Now what I'm going to do is I'm going to distribute this back term here by everything back here. But as I go, I'm going to line up like terms vertically, just like I did up here. So 5 times x squared is a positive 5x squared. And notice I put that right under 3x squared because those are like terms. Now I do it again. 5 times 3x is a positive 15x. Notice I put that right underneath the 4x because those are like terms. Positive 5 times positive 4 is positive 20 at the end. Notice it's at the end away from any like terms. Notice the x cubed and the 20 have nothing over or under, meaning they have nothing they can add up with. They don't have any like terms to combine with. So now what I do is vertically add, right, and simplify. Nothing else like the x cubed, but it does go first because it's the highest exponent. So this is a third degree polynomial with a leading coefficient of 1. All right, now we've got 3x squared plus 5x squared. Well, 3 plus 5 is 8x squared, positive 8x squared. Then you've got 4x plus 15x. That is a positive 19x that comes down. And of course, nothing else like the 20, so bring down that plus 20. So how I was doing the FOIL problems above is one way to continue handling a binomial times a trinomial. Another way to do that is what we call the box method. And in the box method, the way we set this up is I draw myself a nice little rectangle. In the rectangle, I have x plus 5 on one side. So notice I drew a line separating everything. And then I'm going to do x squared plus 3x plus 4 across the top. And then I'm going to divide my rectangle into these boxes. And what I'm going to do to find the answer for the inside of each box is I'm going to do multiplying of their sides. So x squared times x is an x cubed that goes right here. X times 3x is a 3x squared, that goes right here. 4 times x is a 4x that goes right here. Let me put my signs, positive and positive. Now I continue doing that, right? So x squared times 5, well, that's a plus 5x squared. And 3x times 5 is a plus 15x. And 4 times 5 is a plus 20. Now what I do is I look for any like terms to combine, and I still write my answer in simplest form, standard form, meaning start with the biggest exponent and go progressively down from there till you get to a constant term at the end if there is one, right? So I've got my x cubed is all by itself, doesn't have anything to combine with. I do have two x squared terms. So 3 plus 5 is a positive 8x squared. I do have two x terms. So 4 plus 15 is positive 19x. And I do have one constant term for the end that I will just rewrite. Another way to get your answer here. So I just want you to see that either of those ways gives you exactly the same answer. Okay. It's just how you're organizing your multiplications. The bottom line is everything in the front term has to multiply by everything in the back term, or in the back polynomial. Everything in the front polynomial has to multiply by everything in the back polynomial. And then you add as many like terms up as you can. You simplify as much as possible. Ever since our first lesson, we have to go simplest form, standard form, right? We have to be able to do that. Okay. So here we go. I kind of prefer this one, but you know what I'll do? I'll do this method for number 1 and I'll do this method for number 2. And that way you can see them each one more time. Okay. But I'm just telling you, when you see my answer keys, this is the method that I will choose. Okay. So let's begin. X times x squared is x cubed. X times negative 2x is negative 2x squared. X times 4 is plus 4x. Cool. Now let's distribute this negative 1. So negative 1 times x squared is negative 1x squared. Oh, I threw that 1 in there for you guys. Negative 1 times negative 2x. Okay, that's a positive 2x. Negative times negative is positive. And negative 1 times positive 4 is a negative 4 at the end. So now let's vertically add our like terms. X cubed minus 3x squared plus 6x minus 4. There it is. All right, let's use the box method on the other side. We have 2 terms here and 3 terms here, so a rectangle. Oh, sorry. Little off there, but that's all right. We'll figure it out. X plus 3 here and 2x squared minus x plus 5. Got it. 2x squared times x is 2x cubed. Negative x times x is negative x squared. 5 times x is positive 5x. 2x squared times 3 is 6x squared. Positive, I need to put that positive there. Negative x times 3 is negative 3x. And 5 times 3 is plus 15 here. Neato. Let's get our answers together. So 2x cubed plus 5x squared, negative 1 right here, right? So 6 minus 1 is positive 5x squareds. Negative 3 here, so 5 minus 3 is positive 2x, and a plus 15 at the end. There we are. All righty, my algebra friends. I think you've got this, but the best way to make sure you've got this is to practice, right? So that is the best way to ensure that you know what you're doing. I'm going to zoom out so we can kind of see everything here. Now, remember, the very first thing we started out with was single term multiplying together, right? Which really just kind of encompasses our exponents rules from lesson 3. But I want to make sure that you stop and you make sure that you can do this. Practice. There's lots of practice on your next homework. We're going to continue talking about these patterns. Okay. You got this. If you don't, come to class and email me and I will help you. All right. All right. Guys, it has been lovely. Good luck. Let me know what you need.